Well, hello guys, here we are back on the Atwater Kent. I believe this is part 6. Anyway, I told you I'd get to this video too. Got the transformer from Art. I need to do a little touch up on the paint. It seemed like I didn't get my tape on there very good. And it's going to need a little bit of drilling. These holes are just about half a hole off with these 2 screws in place, which is no big deal. It's not that big of a deal. In fact, it's actually pretty easy. Got this painted up. I went with black paint. The only reason is I cannot find camouflage in brown anyway. I can find the olive drab, which is a green. And otherwise any other brown is too light. The only other route I could go is to a town that's close to here, and they have a paint store there, automotive, and I can get them mix it up, but then I either have to come up with a sprayer and spray it myself, or if I use their aerosol system, just a aerosol can that is refillable. I mean, you can reuse it, but it's rather expensive, and between that and the paint and everything, it was going to run me almost 50 bucks. So I decided, nah. Otherwise I drive about 100 miles. I live in a very small area and a very small community, so we don't have a lot of choices. So anyway, I'm just getting more stuff put on and getting her kind of buttoned down. Then I'll have to start doing the wiring. Started working on the capacitors. I was going to paint these silver, but then I decided, well, I don't know. You know, they're going to be underneath and never going to be really seen, so I'm probably not even going to put the bottoms back in. I don't know, I haven't decided yet, but once I get those all done and get them on, then it's the we start wiring it up, putting it back together, and getting that all done. The power supply is pretty much done. I'm just waiting on the tube. That funny thing is, every time I go and check the tracking number, it says scheduled delivery is the 12th. Well, we're a little bit past that. They haven't changed tracking for over a day, so I don't know what's going on with it. Kind of got everything pretty much wired up. Various dropping resistors for the various voltages. These are only temporarily kind of soldered in here. They're not locked down yet. The main reason for that is I'm not absolutely sure the drop on the tube. I know what the manual says, but I've seen that vary a little bit. And plus things, you know, you can do the math and everything, but there's always a little room of smudging and stuff. So once I get the tube in there and then put appropriate loads on, then I can make measurements and determine which way, if I need to replace or change a resistor, which direction I need to go. So if they don't need to be changed, then I'll lock them down a little better than what they are. Got a fuse in, got the thermistor in. Here's the adjustment for the hum control, and it's all wired in underneath here, and then comes up. This will be the going for the A circuit, and this one is all the different B's, and then your B negative, or the ground, and that couples with the A. I mean, it's, well, it would have if I had DC, I guess. In the normal, it did couple together, but I don't do that on this one. Now the one little dilemma I do have, and is going to be interesting to see how well it's going to work out for me, that's going to give me a little bit of headaches, and that's the speaker, or mainly the field winding. The speaker field, according to the schematic, is 8 ohms, and it ran off the A battery, which was 5 volts. So that means it's 625 milliamp draw on that field winding. Now voltage is not a big deal. Yet it's got the same enamel on it as, you know, this power transformer has or anything else. So I'm not concerned about the voltage, it's just that current draw. The more the voltage goes up, the current will actually go down on it. So what I'm thinking about doing is at least attempt to, you got to have DC. Now I can have ripple in it, that's fine, it won't be a major problem, but tapping it in to the B negative side, and then, in other words, it would actually connect into B negative and then go through it and then go to ground. That's one route that you can do, and that's what Atwater Kent did on the various other radios that were AC as opposed to battery, is what they did with their field winding. So I might do that and see if that works. Worst case scenario, these two coupled together produces 5 volts, and I either use that or rectify this, one or the other. But worst case scenario, to develop a DC 5 volts, I could pull off of here and still let this run for the filaments, or I could rectify the whole thing and just run it just the way it was wired up originally. Just have to see, works out. Like I said early on, this is going to be probably a long drawn out process that will take some work to get it to work. So if it wasn't for one thing, and that was simply this cable being in such actual good shape, it wouldn't be quite as problem child. But I only have 6 wires in this cable, so that's the only thing I've got to really work with. Now there's a few things I thought about doing, and although I didn't really want to mess too much with changing too much of the radio, but one thing was, this tube here is fed with 60 volts to the plate, and this one's 65. These are exactly the same tubes. They're both 112As, or yeah, 112As. So this is being fed by its own separate source off the battery, and this one is being fed with the full 180. I could take this one and couple it over with the appropriate dropping resistor to keep it at its 65 volts, or actually 67.5, and then it'll drop through the coil to 65. That would get rid of one. The other thing I could do is do something with the 45 here and do the same thing. Bring a resistor over, either tap into 135 or the 180, either way, and do the same thing. Both would be fairly small resistors. The current on those tubes are not extremely high, and that would free up some lines here so that I could do something a little different as far as the speaker goes. So it's going to be a work in process, and we'll just see how it goes and what it comes down with. Now, how I came up with these sizes. See, normally what a lot of your battery eliminators will do is they'll put potentiometers on these various B pluses. I don't like pots. I like to stay away from them as much as possible, or rheostats, either one. Mainly because, well, anybody messes with this old equipment knows that they get dirty, they get nasty, they get bad, they can go bad, and all kinds of headaches with them. So I prefer to stay away from them and stay with fixed resistors. Basically what I've got going is a divider network running across the full 180 volt supply coming off the regulator, or off the rectifier and through in the filter. Each one of these then drops a certain amount of voltage to get you the various voltages you need. Now, when you figure, you can do just simple Ohm's law to figure this up, but you got to remember that you got certain loads here. So it actually works out to be a circuit like this, and you have your primary load, or the main voltage, which is going to the two output tubes, and that'll be about a 45 milliamp draw off the 180. So that acts as one resistor across your voltage source. And then you got the divider network, but off each divider network you got the various different voltages. So you got works out 135 volts at 5.1 milliamp load, 67.5 volts at 2.3 milliamps, 45 volts at 1.2 milliamps. Each one of these you have to consider as a resistor that's going to be in parallel with what remains of the divider network for wherever they're cut off. Now the little lines is just the current as it flows. Now in DC, when you're figuring up a circuit like it, either figuring it up or at least want to check it after you're done to see if you got everything correct. In DC there's a thing, set of laws called Kirchhoff's laws, and basically there's a couple laws there. One, at any point or node, in other words where there's any connections, the current coming into that has an algebraic sum of the current coming in versus the current going out will equal 0. In other words, if I got 5 milliamps coming into this node, what's coming out of the node, which will be actually down here, will be 5 milliamps, but it'll be the opposite in sign. So when I add the two together, it'll equal 0. So everywhere you got a point, whatever goes in that comes out of that should add up to 0 algebraically on current. The other part of one of the other laws deals with voltage drops, and it states that all voltage drops in a circuit need to add up to the voltage of the source. Now it seems simple. In practice it's algebraic sum, meaning that this voltage here that I'm supplying, when I add all the drops that's in the circuit, it will subtract from this. The algebraic sum will be 0. And I did a little bit right here. But using Kirchhoff's laws when you got a little more complex circuit makes it kind of nice just to double check yourself and make sure that your values are meeting the way they're supposed to be. And basically what you do is with the current and the voltage, you take different loops that's in the circuit and you use the laws to figure out and see if everything's working out to an algebraic sum of 0. If you're trying to figure the circuit, then without having all the information, then you'd use those laws to create up equations and use what is known as simultaneous equations to solve for the unknowns. But it makes it nice to try to figure out where you're at. But that's how you develop a divider circuit. And it's just basically, you just got to remember that you got your loads, they're in parallel, with part of your divider network, depending on where they break off at. And by that being that, then that's how you figure them up, using just parallel circuit analysis. So I guess I don't really have a whole lot else to say on this. It's just kind of plugging along. Kind of got things kind of cleaned up, looking a little better. Like I say, the cord's got a little fraying in it, but it's got several layers of insulation, and that's just on the very outer jacket, so I don't think it'll be too dangerous or any problems. And I'd like to try to keep everything pretty decent looking, or age-wise. In fact, I went out and found me a wood knob to put on here so that it kind of, I don't know, matches in. The only thing it doesn't is this little glass fuse here. I'll probably, once I know everything is where I need it and everything, then probably either wire tie or do something with these wires just to kind of neaten them up just a little bit. I hate to use wire ties. I might lace them, I don't know. And this, in the next video, I should be at the point of getting some of the wiring done on this and getting it kind of buttoned up and everything. And I'm hoping I have a tube so I can do the test on this and see if we need to adjust any of the those resistors, or everything's okay. Now I know they seem light duty, but the currents in your B circuits are pretty low relative. I mean, we're talking, you know, 5.1 milliamps, 2.3 milliamps, 1.2 milliamps, you know. So, and the only heavy one is across the output tubes, which is being fed not through any resistors. It is directly coming from the filter circuit and then directly going out. So it don't have no resistors on it. Only the divider network does, and then they're sharing with the parallel and the series parallel circuit all that current, so that you don't have that much current. Actually, the largest drop is 9 milliamps. Still works out I squared R as being less, like 0.3 watts, so a half watt resistor is plenty heavy enough. So that's why we're using such small ones anyway. So anyway, this has ran long enough, and in a day or two we'll get back to it, and should be quite a bit further along. And you can see where I'm at, and maybe we can do some load testing, or at least see what comes up with on this. So thanks for watching, and for your comments and stuff, and there'll be more coming. So I'll see you on the next video. Bye.